Okay, students, we are back with lesson 2.4. So we are continuing on with stuff to do with linear functions. And this lesson is all about linear systems, which we did in class. I think unit 4 it was. This is where we're looking at two lines or two graphs and determining their solution, which is the place where those lines cross. And so for most of these, it's pretty straightforward. I'm going to go all the way down here to the questions. Um, the first one is a word problem. And so we didn't go over this a lot, but I think you can use common sense to figure out how this one works. So let's talk about the problem. Let's just read through it together. Pedro was riding his bicycle on the bike trail around the park. After he had gone 1 mile, he got a flat tire. He called his friend Matthew to bring him a spare tire. Pedro continued to walk on the trail at 3 miles per hour while he waited for Matthew. Once Matthew arrived at the bike trail, he was able to ride 8 miles per hour on his bicycle. About how long will it be until Matthew catches up to Pedro? All right. So, first things first, let's see if the graphs have the correct information about 3 miles per hour and 8 miles per hour. So we know that the line showing Pedro's movements is going to be not as steep as the line showing Matthew's movement because 8 is going to be increasing fast. And so the slope is going to be steeper. So we have two lines here. In this graph, we have the 3x and we have this 8x. So we can see the 3x is talking about Matthew, or sorry, the 3x is talking about Pedro, the 8x is talking about Matthew. Let's see. So this one also has 8x and 3x. This has 8 and 3, but not with the x. So automatically this is not right. And then we have again 8 and 3. So it's just a question of where do they intersect. And so it's really, honestly, not much more than common sense. If the y-axis represents the place where time is 0, in other words, after however many hours or whatever, 0, we're not ever going to do anything in the negative area of the graph because you can't travel negative hours in a direction. You can only travel positive hours. So the intersection can't be in the negative section and it can't be along the 0. So this is not right because the intersection here is in the negative area of the graph. Here we have a graph where the intersection is in the positive area. That's good. We already eliminated answer choice 3. Last one has the intersection at 0. So that can't be it either. So just using common sense, we know that this is the correct response because the intersection point is in the positive section of the graph. All right, now the rest of these are going to be a little bit more straightforward. What is the solution to the linear system? The solution all the time is always going to refer to the place where the graph intersects. So we don't even need to do anything except find this point among our list. And so remember, x comes first. It's x comma y. So the x is 1 and then the y is 2. So 1 comma 2 is going to be my intersection point. And so that's this answer choice. Next one. Which system of linear inequalities is best represented by the graphs? Now, really, we don't actually need to know much about this except for the fact that we have one slope that's positive and one slope that's negative. And it appears that they all have a positive and a negative, so that's not going to help us. The other thing I can see is that both graphs have shading that are above the line. This blue is above the blue line. The red is above the red line. So that means that both graphs need to have an inequality symbol that shows greater than. So here we have greater than, but then we have less than. So that can't be it. Less than, that can't be it either. Greater than, less than, that one can't be it. So it has to be answer choice D, the last answer choice. And that is all for lesson 2.4.